Hello everyone, in the previous video we have studied about the additive properties of the two complex numbers. So our next property is the difference of the two complex numbers. For example, we have z1 is equal to 9 minus 2 iota and z2 is equal to minus 4 plus iota. Whenever we difference these two numbers, z1 minus z2, we say 9 minus 2 iota minus 4 plus iota, taking real part on one side 9. First we will simplify this. 9 minus 2 iota plus 4 minus iota, so 9 plus 4, then minus 2 iota minus iota, we will get here 13 minus 3 iota. This is the difference of the two complex numbers. Next one is the multiplication of two complex numbers. Here I have taken the example of z1 is equal to a plus iota b and z2 is equal to c plus iota d. Whenever we multiply these two complex numbers, our answer should also be a complex number, which means there should be a iota term in this case. So z1 plus z1 into z2, we can do a plus iota b, c plus iota d. So a c plus iota d plus iota b, c plus iota d. So ac plus iota ad plus iota bc plus iota square bd. We know iota square की value -1, so ac minus bd. Now taking iota common, ad plus bc, which is also of the form a plus iota b. It is also a complex number. Now next properties regarding multiplication of the two complex numbers includes the closure law. It states that whenever we take the product of two complex numbers, for example z1 into z2, the answer will also be a complex number. Second, it is the commutative law. Multiplication of two complex number will be the same. And associative law, it consists of three complex numbers z1, z2, z3, and whenever we multiply all these three complex numbers, our answer will be same in accordance with the LHS is equal to RHS. This is our left hand side and this is our right hand side. Now next one is multiplicative identity. Multiplicative identity, we can say in case whenever we multiply 1 to any number, there is no change in the result. So it is same in the case of complex numbers, such that whenever we multiply 1, like 1 plus 0 iota, we have complex number 1 plus 0 iota. Whenever we multiply 1 with that, our answer will remain the same. For example, let's take z is equal to 2 plus iota. Whenever we multiply 1 to the z, 2 plus iota into 1, our answer will be same, which is equal to z. So this is the multiplicative identity of the two complex numbers. Now next one is our multiplicative inverse. In this case, we have our complex number z, and its inverse is written as inverse of z. It is written as, or we can say it is 1 upon z. So whenever we multiply z with its inverse, our answer will be 1. This property we will study in more detail when we will be solving our further questions. Okay, so next comes the last property of the multiplication is the distributive law. For any three complex numbers, say z1, z2 and z3, it must satisfy two conditions. For example, z1, whenever we multiply z1 to the product of z2 plus whenever we multiply z1 to the sum of z2 plus z3, we will get the answer z1 z2 plus z1 z3. And second condition, the sum of two complex numbers multiplied by the third complex number, it will result the same as the previous one. Let's check here, z1 z3 plus z2 into z3. So this is our distributive law. Either we add two complex number and multiply it with the third complex number, or first we will multiply and with the addition of other x numbers the result will be same. It is the proof here. Okay, so these two conditions you need to learn about this. Now next one is the division of the two complex numbers. Whenever we divide two complex numbers, z1 upon z2, the first condition needs to be followed is z2 should be not equals to 0. So here I have written the example to understand this it is more clearly, like z1 is equal to 2 plus 3 iota and we have z2 is equal to minus 1 plus iota. So z1 upon z2, it is written as 2 plus 3 iota and z2 is minus 1 plus iota. So there is a property that whenever there is an iota in the denominator term, we need to rationalize it first up before further solving the question. So rationalizing, we get 2 plus 3 iota by minus 1 plus iota, and whenever we rationalize, the sign before the iota term gets inverted. So here it is plus, so it will become minus 1 into minus 1 minus iota, minus 1 minus iota. Now first we will solve this. 2 plus 3 iota minus 1 minus iota, and this is equal to the identity a plus b into a minus b. So a square minus b square, so a square minus b square. So we will solve it like 2 minus 1 minus iota plus 3 iota minus 1 minus iota upon minus 1 square of minus 1 1 minus square of iota minus 1. In denominator we have 2, and to solve this further we get minus 2 iota minus 3 iota, so minus 3 iota square upon 2, and now minus 2 minus 5 iota, and iota square is equal to minus 1, so minus 3 into minus 1 will be plus 3 upon 2. Now adding the solving the real parts, minus 2 plus 3 1 minus 5 iota upon 2, which is also a complex number. So we can say the division of any two complex numbers is also a complex number. Thank you for now, and we will start solving few questions to understand it more in our next video. Thank you so much.